Hi there, this is Penelope. This is FS318, Topic 8, Class 2, and we don't need that there, so it's Class 2. And we're going to look at tables and charts, because as engineers you need to be able to present data to somebody in a way that they can see it. So we can look at pictograms, we could look at a table, we could use a simple tally. And if we're going to look at a pictogram, then we'd need some sort of key. Table straightforward, 1, 2, 3, 4, 5, and then 6 would be 6, and so on. We can collect data. This box shows data that's just as it is collected. Here it represents shoe size of females. The shoe size is the variable. And in this case, we're only looking at 40 females, so we would take that as the 40 females would be a population. It's not a sample, it's a population. Here we have a set of data on the length of worms. Now here, these lengths are measurable, right? They are measurable. So in that case, we talk about the data as being continuous. If the data is countable, say the number of people in the room with blue eyes, then that is a countable data, and then we would say the data was discrete. Sometimes it makes sense to actually play around with how we look at the data. Sometimes we might want to put it in descending order, might make it easier to look at. So we could put them in order as we have here in the left-hand block, or it might be better to see it. Some people can see it if it's in a frequency table where we count every time we find a size 4, we make a mark there and so on, and then at the end we count them up. We can then show this data in different ways. We can use a line chart, we can use a polyfrequency so that there were 4 in size 4. So there's that data there, and we're just choosing to start there, and we're just choosing to start there. Or we could do a dot plot. All of these are just representing the same data in different ways, so we can present it differently to people. Now here's an actual example. We will do this example in class. Here is some more data that's been taken and turned into a frequency table, but this time, if you notice, it's not just every single piece of data that's represented, it's a class of data. So we say how many, we look at a score, we look at say 86, and then we look over here and we say, well, 86 is between 85 and 89, so we make a mark in here, and so on for all of the data. And we talk about this as grouped data, and the data is recorded in classes or intervals. Now there's a separate video on this called Classes and Boundary Widths, I think. Something like that. So more of this is explained in that video. We can also use bar charts. We can use histograms. All of them show different ways of representing the data. Again, we will do this example in class. Now, I said we'd do this one in class, but here are the answers for the earlier one. We've done a cumulative frequency simply by taking the data, putting it into the class, and then saying, well, okay, there's 1 in the first class, and then 2 in the second class, so 7 in the second class, so 1 plus 7 gives you 8. And then there's 11 in the next class, so we add that on and we get 19. Then the next one we add on 12 and we get 31, and so on. So by the end we've got 40, which is how many we have in total. Stem and leaf, you've probably seen these at school. Not terribly helpful for large sets of data, but for small sets, yes, they are useful. The cumulative frequency curve, figure 19.7 from your textbook, that's sometimes useful just to see it, but it does have that typical S-shaped curve, S-shape. Here's some more data on exams. Again, we'll do this example in class. It's too hard to do here. Self-explanatory. Sometimes data can only take a specific reading. Heights can only take a value within, say, 140 to 200. The only restriction there is how accurately we can measure it. Here's some data that we looked at between, say, 140 centimetres tall and 200 tall. Classed them, we've grouped them. So we're not looking at individual readings. We're saying, well, here's a reading, 150, that fits in this group here. 174, that fits in that group there. And then once we've got the data, we'll say, well, there's 3 in the first group, so 3 in the first group there, 150 to 154, up to 3, so it's that group in there. And the last group is 195 to 199, that would be that group there. And there's 2, so you take it across and you can see that there's 2 in there. For this data, one of the things that we could find out is the range of the lengths of the phone calls. These are phone calls over a 2-week period recorded in seconds. So the range here would be the longest to the shortest. That's something that we could find. We could find the shortest call, we could find the longest call. We will do this one in class. Here's some data on apartment types and bedroom types. And one of the things we can look at here is it's a different way of recording the information. This is all the information for year 1. So year 1, we're looking at the data more vertically, and we've represented it vertically. The information that we could use here is the relative frequency of a particular thing occurring. Say, in this case, let's look at the number of 4-bedroom apartments sold. Say, sold in year 1. So we go to year 1 and we look at the 4-bedroom apartments. There are 24 of those. So we're going to say, well, that's 24 out of the total, which would be 24 plus 38 plus 44 plus 64, make the line a little bit longer, plus 30, and then to turn it into a percentage, we'd multiply it by 100 over 1. And that would give us, if you use your calculators, that would give us 12%. So it's a frequency that will tell us that there are 12% of 4-bedroom apartments sold in year 1 of this data. I'm sure you all know what a pie chart is. A pie chart is where you just convert the information into angles. So if we've got the information here, the retail price of a product, $2, it's made up of 10 cents materials, 20 cents labour, 40 cents research and development, 70 cents overhead, 60 cents profit. So what we've got is that the $2 corresponds to, or 200 cents, corresponds to 360 degrees. So 10 cents is 10 cents out of the 200 cents. That has to be a fraction of 360. So it would be 360 times 10 200ths, which is about 18 degrees. So then on our circle, using a protractor, we'll just start somewhere arbitrarily and we would measure off 18, which is not very much. Then we would either use a colour code, or we could, I can't really, but we would squeeze in there that was materials. And you might say it's 18 degrees, or you might say it's 10 cents or whatever. Excel can do this really beautifully as well. So I won't do that diagram there, it's very hard to draw a perfect circle here, but we will do this one in class as well.